And hello again, Algebra 1 peeps. This is now Chapter 5, Section 4, Solving Compound Inequalities. And have no fear, you will see me wearing the same thing I was wearing in the last video. But that's just because I'm doing them in the same day. Don't worry about it. It's not like I wear the same thing every day. But anywho, today we are learning how to solve compound inequalities. And compound inequalities, like the word compound indicates in English, you basically take two words and make them into one word. So basically you take two inequalities and make them into one inequality. And so the first type of compound inequality is what we call an the form of and. And an and compound inequality is only true if both inequalities are true. And basically that kind of reminds me of like if your parents give you a condition. You know, like they might say, you might ask them to go to the movies, and they'll say, well, you can go to the movies if you wash the dishes and clean your room. That doesn't mean that you can do one of the two chores and then go to the movies. It means that you have to do both before you can go to the movies. That's basically the idea here, is that it's only true if both inequalities are true. And it's graph, when you do graph the solutions, it's where the two inequalities basically overlap. And we call this the intersection of the two. And we have a symbol that the book doesn't really use much, but I tend to use a lot. So the symbol for an and compound inequality is basically like this. It's kind of like a U upside down, but you can remember it because it kind of looks like a rounded A. Okay, for and. So, example 1. One of the things that happens when you have an and inequality is that they'll do this little thing where they write it as a sandwich. I call it a sandwich because instead of it having two sides, there's kind of like three sides. There's this guy, there's a symbol, there's this guy, another symbol, and then this guy. So there's like three parts. There's like this part, the middle part, which is in between the two symbols, and then the other side. So basically, we call it a sandwich because you've got like your bread slices, if you will, and in the middle you have like your filling. It's just the way that we refer to it. I do want you to know that you can solve this inequality as it is, but if that makes you uncomfortable, what this is really saying is that negative 2 is less than or smaller than x minus 3, and then in turn it's also saying that x minus 3 is smaller than 4. Okay? It is important that when you read a sandwich statement that you understand that it only works because the transitive property applies. In other words, if negative 2 is smaller than this, and this is smaller than 4, then negative 2 should be smaller than 4. And in this case, it's true. I say that because it's not appropriate for you to write this the other direction. You cannot make sandwiches out of greater thans. Because if this said greater than, you would be saying something like negative 2 is bigger than x minus 3, which is bigger than 4. And so then negative 2 should be bigger than 4. But negative 2 is not bigger than 4, so it would be a false statement. So you don't want to do that. No sandwiches for greater thans. Only sandwiches for less thans. Okay? So the other thing I wanted to let you know is that you can solve this by treating it as if this was the middle part is actually the part that you want to solve. So you can solve the two equations at the same time. You could say plus 3, and then plus 3. So instead of adding 3 to both sides, you kind of add 3 to three sides. And then what's going to happen is they're going to cancel here. You're going to get x less than 4 plus 3 is 7. And over here, 3 minus 2 is 1. So basically, x is between 1 and 7. It has to be, 1 has to be smaller than x, but then x has to be smaller than 7. And 1 is smaller than 7, so we're all good. Another thing that you could do is read the inequality from the inside going out. You could say x is, if you read this direction, x is smaller than 7. If you read it this direction, you're saying that x is greater than 1. So if x is smaller than 7 and greater than 1 at the same time, then you can solve the solution that way. Alright, so I want to show you how you can do this. If you don't like doing it all at once like this, you don't have to. You can actually write this as two separate inequalities and solve it that way. And the way that you would do that is to basically go with the first one first, the first two parts, and write negative 2 is less than or equal to x minus 3, and then leave it there. Don't go, once you get to the next symbol, just stop. So that's your first inequality. And then you put your symbol and, at the same time, and then you write again, starting from the middle, x minus 3 less than 4. So now you have two separate equations, and if you want to solve them that way, you can do that. It might make it a little easier for you at first. So x dimension is 1. And in this case, it's backwards now, so you want to go x, and see how like it's the greater than here? You're saying 1 is smaller than x, which is the same thing as saying that x is bigger than 1. So there's your solution there. And then over here you add 3, and you get x is less than 7. So those are your two solutions, or your two parts of your solution. Now I want to show you how you would graph them. In either case, you get the same answers. So when you're graphing it, it talks about how the graph is where the two inequalities overlap. So you're basically going to graph 3 of these things together. So I'm going to try to do that maybe here. Bear with me, I don't have that much space. I'm going to make 3 number lines to hopefully show you what's happening here. Okay, we know that in the first one, I'm going to put the zeros all in the same place. 0, 0, 0. And then we're going to get a 1. And then 7 is going to be way over here somewhere. Okay? The first inequality tells us that x is greater than, and these are all going to be x's. X's are greater than or equal to 1. So that means I'm going to put a dot here, and greater than or equal to 1 is going to be like this. All right? In the second one, I'm going to get that x is less than 7. So it's going to be open, and it's going to go this direction. So then it talks about how the graph is where the two inequalities overlap. So you can see kind of where they're overlapping here. This is the only place where you have solutions to both. If I go bigger than 7, the second inequality won't be true. If I go smaller than 1, the first inequality won't be true. So the only time that they're both true at the same time, remember wanting to both be true, is the overlap. So we're going to start from here to -7 and only shade in between. So in this case, using the arrows is not really that helpful. You want to do the shading. So our final solution is actually this third graph that I've got going on here. You can do the first two to kind of help you get to this point, but that would be your answer. And that would make sense because x is between 1 and 7. So either way, you get that graph. So now I want you to try this little guy. There's A and B. And then I am going out of order here. This says example 3, not example 2, because it's example 3 in the book. But I thought this was like a better example for the next step, because I want to go into the or case. Or inequality, or compound inequalities are true if at least one of the inequalities is true. So one could be true, or both could be true. Okay. Its graph is the union of the two inequalities, so you usually put them together, but there's no overlap. And the symbol that we use for that is this U for union. It doesn't look like an O for or, sorry, but it is a U for union. So there you go. So I'm going to show you how this works. So in this case, you can see how you don't put ors as sandwiches. You only put ands as sandwiches. So you can see how they put the word or here instead of using an actual sandwich in this case. So you have the two separate inequalities. And basically, we need to solve them both. So I'm going to subtract 7. And 13 minus 7 is 6. Divide by -2. And because I'm dividing by negative, my symbol is going to switch to a greater than or equal to. 6 divided by negative is -3. So there's the first part. Okay. And then over here, I'm going to go and subtract 12 and get 5m greater than 25, divide by 5, and m is greater than 5. Okay? Okay, so now I wanted to show you now why this doesn't work when you write a sandwich. Let's suppose that you wanted to write your answer like we did earlier with the ands. Then the first rule is when you write the numbers, the values, you have to write them in chronological order from left to right. So -3 comes before 5 on the number line. So you have to put the -3 there, and the 5 has to be on this side of the sandwich. The variable always goes in the middle. So now you have to make sure that the symbols are facing the right direction. This symbol has the closed side, the arrow pointing to the 5. So that needs to go like that. This guy has the arrow pointing to the -3, so it needs to go like that. Did I do that right? Yes. Okay, and that doesn't even work in this case because they're facing in different directions. So not good. All right, let's suppose that for some reason you wanted to write it like this. The problem with this is that you're saying that negative, first of all, it's not the right statement. Secondly, you're saying that -3 is bigger than m, and then m is bigger than 5, so that means that -3 should be bigger than 5, but clearly -3 is not bigger than 5 because it's negative and 5 is positive. So for those various reasons, you don't want to do that. So never put ors into sandwiches. It's just not going to work. So you have to write them separately, and then we're going to graph our solution, and they're going to be the union. So again, I'm going to go ahead and show you with 3 different graphs. We have more space this time, so I can put them a little bit further apart now. Our variable is m for all of them. We're going to put our 0 in the same spot for all of them. And then we have 5. Okay, talking about how I don't care, I'm not that picky about things. We know that the distance from 0 to 5, it should be bigger than the distance from 0 to 3. So I don't really care exactly where you put it, but I probably shouldn't put -3 way over here because it should be a smaller distance. So I'm going to put it over here. And we can see how this distance is shorter than that distance, which would make sense because the distance from 0 to -3 is smaller than the distance from 0 to 5. The first inequality tells us that m is greater than or equal to -3. So there we go. And then we have m is greater than 5. So here's greater than 5. And that wasn't equal to, so I should have done that. And then greater than 5 is here. And so now we want to put these together, so the union, okay? And I think that I might have written this down wrong because I'm not understanding why I'm getting these weird answers. M greater than or equal to -3 and m greater than 5. Okay. Yeah, that's right. They just wanted to give us a weird one. Okay? Normally they don't do something that weird right off the bat, but I guess in this case they did. So what's happening here is that we want to put them together. Remember that in this case, the solutions are going to be anywhere where at least one of them is true. So at -3, the first inequality is true, but the second is not. But one of them is, so therefore we're going to include it in our final solution. And then all through here, okay, all through here from there through to 5, the first one is true, the second one is not, but we're still going to include it. Even at the point 5, the second equation is not true, but the first one is. So it only has to be one of them, so we're going to include 5 as well. And then everything beyond 5 is included for both. There's overlap there, so we're going to end up with this as our solution. Everything from -3, so everything that's greater than or equal to -3. So our final graph is going to be this one right here. I'm going to highlight it for you. And there you go. And now you can try these 2 little guys. And then we're going to go back to example 2, which is a word problem. And then we're going to let you do a word problem, and then we'll call it a day. Very short lesson today again. Alrighty, so in example 2 it says, the human ear can only detect sounds between the frequencies 20 hertz and 20,000 hertz. That's a really large span though. Write and graph a compound inequality that describes the frequency of sounds humans cannot hear. And I went ahead and I highlighted the word cannot because if you don't read it right, automatically you might think, oh, they want to know, like, that's easy. It's just going to be between 20 and 20,000. But it's not, okay? The sounds that humans cannot hear is going to be F for frequencies, okay? You can hear everything between 20 and 20,000, but you can't hear stuff that's smaller than 20. So that's going to be F less than or equal to 20 represents frequencies that we cannot hear. And then you have, or if it's larger than 20,000, you can't hear those either. And we shouldn't put the equal to because you can hear 20 because it says you can hear 20, but you can't hear less than 20. So you just want to put F less than 20. So that's basically our compound inequality. F is less than 20 or F is greater than 20,000. And then it says it wants us to graph the solution. So we're going to make a number line. In this case, I'm not going to do 3 number lines. I've kind of showed you how that works already. But we basically want maybe a 0 over here. And there's like a 20. And then way the heck over here, that's a big number, there's a 20,000. Okay? So the frequencies that we cannot hear, and actually I'm beginning to think that this should actually be an equal to now. Because if it says between, it doesn't mean that it includes the endpoints. It's between 20 and 20,000, not including 20 and 20,000. So I think that we're going to do that. So that means that we're going to go with a solid dot here. And less than that will be this direction. And over here we're going to go with another solid dot. And greater than that will be this direction. And you can see that there's no overlap there, but you want to combine the 2 pieces together. And that's what your graph would look like. Alrighty? So now you can try this do-it-yourself question. And once you have completed this one, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching. Bye-bye.